Welcome everyone to the IoT Happy Hour. We've got a fantastic guest this evening, actually a buddy of mine, Volkmar, resides out in the wine country, I'll put it that way, California, Sonoma Valley. But Volkmar has been working on his doctorate in IoT. So I look to him for a lot of expertise and so forth around IoT issues. So this evening, we're going to be discussing microgrids and just the effect of a microgrid within the whole sustainability green movement and what that looks like, along with what are some of the typical issues that you deal with microgrids. We'll kind of give it a CFO look at some point. And of course, obviously, we'll tie this back to the types of services and device connectivity stuff, whatever, around IoT. I'd like to go ahead and welcome Volkmar. And if you want to go ahead and kick it off, Volkmar, tell us all about microgrids.
Well, thank you. Thank you so much, Gary, and thank you so much, Ed, for letting me speak here. Just for clarification, my thesis is in economics and not engineering, so I mostly research on the economics, micro and macroeconomic implications of IoT and energy and how that will influence the future of economies, so to say. But of course, there are a lot of technological aspects to it, but just make sure I'm not an engineer. So, why microgrids? Microgrids, in my opinion, will play a very important role in the energy future. Right now, we're relatively in the beginnings of microgrids, and but I expect in the future microgrids to merge together into a new electricity infrastructure. And managing those microgrids will require IoT and sensoric and cloud capacity to properly manage the interdependent energy sources and grids and grid connectivity. And I'm now sharing my screen, and I hope it works. And one second. So I'm going to start with a market overview. So basically, the global microgrid market is growing. Is going to grow substantially in the next 10 years, with a average growth rate of about 22%, in North America 13%. There are different numbers in regards to that, but it's gonna grow. It's mostly driven by startup and large companies that have been very active in the automation market previously. And just to name a few: Hitachi, General Microgrids, ABB, Schneider Electric, Siemens, Eaton, and General Electric, traditional automation companies. The interesting thing, and that's where I will go later, is while all these companies want to play there, the biggest company with the most installations is a startup out of Texas. that figured out the right way to scale microgrids. So it's mostly driven by demand for uninterrupted power supply and government mandates and electrification of vehicles in the future. So here you can see kind of what are the customers currently in the United States. There's a lot of universities, institutions like Princeton University, then community, commercial, not so much, military, and remote, non-connected. What I have seen now also is here's again a world market overview, starting here from 1 gigawatt going up to 8 gigawatt capacity. I mean, if you think about that, it's still in its infancy, because 8 gigawatt, I mean, that's like, I don't know, 4 nuclear plants or 4 coal plants or something. I mean, compared to the current market with several terawatts of capacity, it's still in its infancy. Here in the United States, basically, we have divided this into different regions, and you can see here actually Texas, the Texas region, Southwest, and among the southwestern states, Texas is by far the most advanced in microgrid installations and a number of microgrid installations. So you have 399 megawatt, even more than the West Coast. Then comes the Southeast, but which many more people here. So, and then Hawaii has a lot, I mean, in comparison to having only like 2 million inhabitants. Makes sense, because there's a lot of opportunity there in military. This is from the Department of Energy. You can also look it up. It's a really cool feature, because what you can do is basically see on a map all the microgrids across the United States here. And you see the large concentration in Texas. You see Southern and California, and here in the northeastern states. And I just took one out here. If you double click on one of those dots, I just used this because the Stone Age farm I've visited, it's a microgrid here in Sonoma at a winery. And there's quite some information out of there about them. And it's really interesting, because they integrated different sources of energy in a very sufficient and efficient way. So all across, we have 683 microgrids, and actually in the United States, and one of the big players I told you, Texas, is in Enchanted Rock. They have, you know, the HEB supermarket chain. They cover that resiliency in microgrids for all of the supermarket outlets. And the biggest, and they have also many other projects in the United States, for example, for data center in California, and has also executed large microgrids in Houston with water facilities and so. Yeah, I just wanted to bring this up because obviously the audience is in Texas, and I thought this makes sense to share. So when we look at the ecosystem of microgrids, you have business models, the business side, the regulations and the markets, the management, basically data management, tools and method and control systems, and then ICT systems, where the IoT sensors are integrated, and then the data is visualized and put into context. And then you have the infrastructure. Coming into the business side of things, they're different. So generally speaking, the upfront costs for a microgrid are quite high. Yeah, and normally the case is that basically the customers don't want to come up with a capex, capital investment. So the providers of the microgrid, the builders, come up with financing models. Yeah. So for example, they have investment arms that will do the financing, and then the one option is site lease, where the customer basically pays a monthly annual fee to use the system, and part of the savings and the revenues generated will go back to the microgrid provider. Then there's power purchase agreement, where the customer pays the provider also single payment, but only on the power they use, and the rest of this, and it's on a $1 per kilowatt hour rate, and on a flat rate, often lower than the cost of energy from the grid. And it depends on how much subsidiaries there, and tax breaks and so forth. Then the hybrid power purchase agreements, where the thing is, and then spot sales, the ownership is handled by the microgrid provider, who realizes 100% of the savings, and the annual tariff covers the O&M services. And so all in all, we have a lot of investment models where basically the cost of the capital investment is being shouldered by the microgrid builder. Mostly they use some outside financing of some big investment like the Blackstone or other equity investment funds. And then they basically make sure that the installation is paid for, and then it's paid back through the saved money, plus the resiliency it provides. So this is just a curve here. If you look, solar storage, high capex, lower OPEX, and then you go further to solar storage, generator, lower capex, but higher OPEX because you're gonna use fuel, and then you further right, solar and generator, again, you have even less capex and more OPEX, because actually you use even more fuel. And you can make the assumption that the higher the renewables, and by renewables we mean like the solar or windmill or something, these hard assets, the higher the capex is over time. The capex is, and that means basically that it's easier to calculate your costs over 20 years per kilowatt hour, but you have to come up with a larger investment. So what are the main drivers for microgrids is, first of all, resiliency. We have a strong increase, and this is going up again, of extreme power events, storms and weathers that influence the grid. And you will probably much better remember than me the last year's power outage in Texas. And if you think you have a supermarket, you have inventory of 300 to 500,000 of goods in the freezers, that's a substantial amount of money, and your diesel generators only last for 2 days and then you're out. And that's exactly why that Texas microgrid company runs on gas, because gas is coming through pipelines and basically is unlimited supply. And they were able to manage, help their customers in that extreme situation last year substantially. So other drivers are grid instabilities, increasing dependence on electric infrastructure. I just mentioned the microgrids, but also I just mentioned the microgrids for data centers. But also electric charging will come more and more on and will bring disruptions and instabilities to the grid. So that's like interviewing project owners and customers of microgrids of 168, and you see here, out of so many points, why they chose to have microgrids is reduced energy use, reduced energy bills, and the financial benefits of it for the consumers and for the operators, improved system reliability as the most named, and then also reduced peak demand. So there are different business models around that, from peak shaving to feeding into the grid, that will increase the value of a microgrid. So this is kind of like a little scheme I made here, and how many of how we could look at that. And so putting this together, the advantages of microgrids is reduced energy consumption of intelligent microgrids, optimization of gensets and batteries and inverters, transparency for energy usage, minimized downtime, improved asset lifetime, longer service intervals, capex, data integrity, and local analytics. But there are barriers of scale. first of all, I mentioned financing, so you have to make sure, basically, when you approach a customer, you have the financing right. Then all the stakeholders need to be properly managed and educated, and you need to make sure that you properly integrate and make sure you have interoperability between your assets, and that also goes into cost predictability of energy production, and there's quite some complexity of deployments by region and tariffs and so forth, and so there are a lot of things going into it. When you look this year up here, this is the state microgrid laws. Interestingly enough, Texas managed to be the leader in microgrids without substantive microgrid law. So, but here you see those different jurisdictions and how they will inflict on the building of those microgrids in different ways, depending on the legislative process. And then there are different microgrid programs with incentives. I brought up some here, which are found in California, Oregon, and Minnesota. So what's a microgrid? Basically is a conglomeration of different energy sources, storage, and controllers that are intelligently managed to reliably provide electricity or backup to institutions. And basically you see here the solar arrays, the battery, the generators, on-site controls, the platform. Everything has to work together to have an optimized microgrid running. Most companies that run microgrids also use cloud platforms and command and control centers to so anyway, software, economic optimization, hardwares, batteries, inverters, site controllers, financing, compatible DERs, and project implementation. Those are the 5 ingredients to build a microgrid. And here I just put this, which I mentioned earlier in the beginning of my presentation, how microgrids will eventually in the future merge with the traditional transmission and distribution energy system, which we still have, where you have on the left side the centralized energy generation going through a traditional grid, but then you enhance this on the right side with residential microgrids and industrial microgrids. I don't know how it's in Texas, but in California there are smart meters everywhere on the private solar private houses and so forth, which you obviously then need to measure it, but we still don't have a feed-in tariff law. So but obviously that's a technology you need. So, and that's how I envision it to be in the future. So coming to the microgrid controller is basically managing the renewable power and just spot abnormal behavior and demand charge management and resiliency. So it's a brain. And while some companies provide some controllers on their inverters or sell it with them, it's a challenge to manage all these different controller systems. So I come to it later. And so the centralized controller in the center of the application controls all these different energy assets in a way that optimizes that microgrid. And here I have, so one of the players, I mean, you can see it, Siemens, comes from the traditional automation world, so has still this control SCADA system that then integrates with a grid edge controller and those different field level applications. But I mean, this is, I think, not ideal for the future, and I will show the centralized systems for decentralized energy resources. In my opinion, it doesn't give the flexibility. That's why I think the decentralized systems, decentralized distributed control is much better, which basically requires a controller on every asset and then manage this in a decentralized way. Here's just some competitive landscape, decentralized, centralized. So the difference is basically of the decentralized way is that you have basically an object-oriented system, and that reflects better the complexities between the different energy assets, which basically means that energy assets not only interact with each other, but there's a economic exchange level based on game theory, optimizing the different assets between each other, giving much more stability to the system. And this is one of these controllers that's being on each of these energy assets. And it's a very new form, was developed in MIT, and is a very good way to optimize the resources and enable the modular microgrid. Also allows much more easy and to add new energy resources to an existing grid versus a centralized approach. Here's another. So basically on each of these energy assets, you have the controller then, and you have an overarching intelligence structure that's kind of independent of the independent energy sources and can be managed by the cloud. So the hardware acts as a protocol gateway and an aggregator, and the software provides on-premise remote data access, and the technology, and it's technology agnostic. That means like the manufacturers and utilities and developers can avoid a lock-in and because what we currently have, and I come to that in the next points, that is that microgrids, there's no real standard in how to properly communicate the assets inside a microgrid. So you have to do that every time new, and that's quite costly. So again, on the big picture, also what I showed before, you have the distributed energy resources, as I said. You have to manage all these different assets and the weather profiles, what the weather will be at which time of the day, and predictions. You have utility tariffs, electricity prices, demand response. Basically, when will you feed into the grid? When will you buy energy from the grid? How to avoid peak demand costs and so on. You can manage all this with a microgrid, yeah, and proper microgrid controller intelligent software, and then you have a user interface, basically where you have all these assets on an interface, and this again brings it to an even higher level of managing those different assets. And this is from a utility level. This is from a software, cloud software that was developed by a utility in Southern California, and they're trying to manage the whole grid, including these distributed energy sources. This is just an example of another company that just to show you the interfaces, or basically the digital twins. You can then double click on all of these different parts, like the gensets, and manage and put certain information in there. So again, those different system stages. And yeah, I had this before. I mean, so then I just to give you some economics, this was a big project in California. Off-grid generates 200,000 in energy savings in island modes. So previously there was just a generator, 200 tons of savings, carbon, and you see here they were funded from the California Utilities Commission, partly, and had a DOE award. And you can see here the different actors. I mean, basically control hierarchies, what is managed here, the weather station, the power meters, the SMA inverters, the battery came from Tesla. As I said, there's a battery management system, and you have a inverter system and so forth. To manage all of this is not optimal necessarily. So if you have an overarching above intelligence system, is, in my opinion, much more helpful. And then you see here the savings that were created due to the microgrid on the right side. Yeah, quite substantial. Those are the bills before and after. Yeah, here again, savings. So this is the Santa Rosa Community College. This here also the load profiles, and you see how you created a demand reduction through the solar is the green here. Obviously in summer much more than in winter, and then in winter the demand is higher, that needs to be get from the grid. But overall, also substantial energy savings of 330,000 and demand savings of 170,000 a year. Just now going shortly into the, and I mentioned that already, the challenges is basically often underinvestment in O&M, and so then it's suboptimal management of the microgrid later. Then the standardization until now is all PLC SCADA system controls, in my opinion, don't allow for enough flexibility for growth and scale of those systems when they will connect eventually to something larger. And so it's still kind of a new industry dominated by old automation infrastructure. And that's just my personal opinion. And then you have to coordinate all these different players. So one needs to be aware of and educate about the weaknesses and the design and integration challenges. And there needs to be more, in my opinion, technology, and needs to be more look at how you can manage that better, other than like old traditional, basically technology from the 1970s. So the outlook, I think we will have the main drivers for microgrids, in my opinion, will be fleet electrification, because it's mandated, and then you build like microgrids around charging station, and there will be tens of thousands of those, and those will be like financed through the electric cars or fleet managers. And we will see how fast we can scale to that, to providing this. And what we see a continual growth in the commercial, industrial, and the institutional campus ways, because of grid stability, and then institutions, they get a lot of money actually to switch, and then community microgrids and military microgrids, and the utilities to some degree are engaged. Some are more, some are less, but they will have to recognize to live with more and more microgrids. So those are some of the utilities that got quite engaged. And this is basically the presentation. More than happy to answer any questions that might come from the audience.
All right. Does anybody have any questions? Because if you don't, I do.
You covered a lot of ground. That's awesome.
Yeah.
On the subject of community microgrids, that seems like the most practical application. For instance, like a geothermal well, the cost of digging the well is pretty extreme, but the more homes you can tap into a single grid, the more efficient that sunk cost is going to be. in the US, it's pretty difficult to get multiple private individuals to participate in something like that. Has there been anything in Germany or in other areas where they've been able to create groups that share energy that way?
Yeah, I know. Yeah, I've heard of a couple of projects. So the advantage in Germany is first of all that you can already trade. There's a real you can already trade the energy from distributed energy resources. They're what we call virtual power plants, which basically aggregate microgrids through the cloud and then buy and sell the energy on a exchange, which is in Leipzig, energy exchange. So far, Germany is more advanced. The other thing that is in Germany quite. I think the decentralized energy, let's say, infrastructure. We have very, very, very big players, but we have also communities who can basically run their own affairs, like whatever the Munich power company and what. So yeah.
The elephant in the room, you didn't address it at all, and that is billing. If you can't bill for it, can't measure it, it's a hobby. Right?
Yeah.
You want to do, you're advocating distributed using a microcontroller on every grid. Who stands in the middle and regulates this? Who makes sure it isn't? Because you also talked about this using game theory to determine what pricing of this stuff is. Sounds to me like that's more
internal. That's an internal mechanism. You have where you have laws. So this is all behind the meter, yeah, in California. And I mentioned that when you want to interact with the grid, you need smart meters, but the smart meters are already everywhere, but they're not being used.
but they're owned by the utility, and the utility is probably not going to want to allow me, if I have my own voltaics, be able to take advantage of the meter. Otherwise, I have to pay them a piece of it.
How you have to see it, I mean, you have to have mandates in the different states that basically, even if it's owned by the utility, the smart meter, and then the utility has to basically buy, we call that in Germany feed-in tariffs, has to buy your electricity at a certain market price, but this is not happening in the US, at least in California yet.
Is the lack of a single grid in the US? Right?
No, it's not that. It's it's a legislation in the different jurisdictions in the states that kind of lacks that. But in Texas, it's more advanced. Actually, I mentioned that. So what's happening here? I showed you the microgrid here for the winery. It's all behind the meter. Basically, then it's just a demand response to the supply. But in Texas, for example, I mentioned the HEB supermarkets and the Texan company. They have arrangements with the local utilities to feed in electricity, and that's how they finance part of it, which is then it's called. But you can also do that behind the meter as peak shaving. Yeah. So basically, when the electricity price is the highest at the time it's the highest because it's the highest demand, you can start producing more from your microgrid or utilize your batteries which you have filled. just for example, like whatever, 6 o'clock in the evening, prices go up. You have fed into your batteries the whole day with solar, and then you reduce your demand from the grid, use your batteries or fuel cells to avoid the peak pricing, and also help the utility basically on this times with less usage of the grid. You know, it's both ways. It's not only negative for utilities, because if you can shed supply needs for the utilities, you're gonna have yeah, you need less capacities in the end, and can use current capacities in a more efficient way.
So you mentioned the fact that it's behind the meter. In that case, who's typically the owner of the smart grid? Infrastructure owner?
So as I said before, I mean, there are different possibilities, but when I talked about the financing models, most of the financing models currently seem to be that the owner is the builder of the microgrid, and uses a investment company like Blackstone or another big equity company to build the installation, and then basically either sells the electricity back to the user, or has some form of sharing or leasing agreement. But then, of course, I mean, like the universities, they own their microgrids themselves. They got the subsidiaries, but some you have to somehow the bill has to be paid.
So earlier you made a comment about the fact this isn't always all negative to the power company. Are you implying that microgrids actually increase the reliability of the grid?
Eventually, you know, but I mentioned in the beginning of my presentation that basically, I mean, the capacity of microgrids currently is minuscule compared to the terawatts of energy that's being produced. But eventually, my hope is that all the big solar, wind, and so forth installations become microgrids, so meaning they get storage and everything, and that provides grid stability. And you know, there are some utilities like Enel from Italy that run a lot of microgrids around the world as a business model. Yeah, so it's the utilities are not prevented from, as far as I know, engaging in this microgrid market themselves. You know, I mean, they own solar fields and so forth. So, but it's all down the road, and my estimation personally is it will only get to something scalable when we have thousands or hundreds of thousands of charging stations, or millions even around the country, because that will really utilize a network where it makes sense. But that's just my personal observation or personal prediction.
So you basically said, you know, that makes sense to me. I guess I'm asking the question is, how do you know if microgrid's right for you?
Excuse me, I didn't.
How do you know if a microgrid is right for you? If it's something you should look into and to invest in?
Oh yeah. Okay, so I mean, how do you know it's right for you is like what, I mean, let's start for a business. Why was it right for HEB supermarkets? Well, because they avoided the breakdown in last year, and their food didn't spoil. And I don't know. Let's say you have each. I don't even know how big those markets are. They're apparently quite big. So imagine you have, I don't know, $1 million of goods in each supermarket. That's with $150 million of goods that would have been spoiled. That's a excellent payback, I would say, from their microgrid installation.
Did you have a question?
Yeah, building off of the kind of the robustness of the grid, and the redundancies. I think as at scale, you would end up with a grid that would be very rare to collapse across a broad section.
Yeah.
But the bigger risk that I would, kind of the point of my question is, we know the problems of an aging centralized energy grid. Have we thought about the problems of an aging decentralized energy grid? So if my module and my Internet of Things, we solve battery storage, we solve that. And now there are 50 million modules with aging firmware and different products that are managing this grid. If mine goes out, there's very little rationale for an energy company to come to my house to fix that. Have we thought about what a decentralized system might look like after 30 years, where you don't have that major kind of public monopoly managing the United Grid?
Well, I want to make a joke now, but when a baby gets born, not a lot of people think about what's going to happen when he's 80. But I think the only my thinking would be is the only thing is the economics. Yeah, and there you point rightfully out a big risk, because the traditional utilities have been around for hundreds of years. They are public, they're financed, they're not going to go down. With microgrids, we don't know. Each case is different. The only thing, the business goes out of business and there's no more microgrid there. Yeah, so it will be probably very different according to the application. The incentive is, of course, for those. It's an economic principle. Yeah, if you don't have the electricity anymore, you're out of business, and so you better make sure you have your infrastructure in order.
James got a question.
No, I was just gonna make a comment that it's not just the microgrid that you have to worry about in this instance. It's also the communications network. Because about 3 million solar panels dead in the Verizon 3G shutdown race. Right? So
Yeah, that's also
Right.
one of big challenges right now, that inverter companies basically going out of business and so forth. That's what I pointed out to. That's why I think you need an overarching structure that is not necessarily dependent on the management of every single asset on its own management system. Yeah, that's probably not sustainable. So there will be, I think, eventually super microgrid owners, like the similar, maybe it will be the current utility companies who eventually then own thousands of microgrids as well, or there will be other companies that will own, like Tesla, huge clusters of microgrids. There has to be, for many reasons, a concentration of ownership for the reason of normating everything. And you pointed rightfully out the maintenance and lifetime issues with those microgrids.
Andrew?
Just a question. So, I mean, we're used to electricity providers now are classified in the United States as utilities. So they operate under a very, a slightly different set of rules because they are utilities. So are you saying that in order for these microgrids to work, there would have to be some sort of change in, I'll say legislation, but basically the rules that they operate under would need to change? So do you know what kind of changes there would need to be to the rules so that these microgrids could proliferate?
Yeah, so in my opinion, the markets need to be opened. There need to be some form of interoperability and feed-in tariff and exchange like in Germany. I mean, I'm not saying that Germany is the best, but it's much more advanced in economically integrating those. Otherwise, you end up with only with island solutions everywhere. So yeah, I think that's the opening up of the electricity, and it's already happening in parts of the United States. So you need a deregulation.
That's my follow-on question is, I'm interested in where is it happening and what is happening when you say deregulation?
I'm not in detail familiar with the different state initiatives at this point, and there's a lot of politics going on in behind the scenes, particularly here in California, that have prevented those measures so far. I don't know how it is in Texas. There are certain clusters here in the United States that make progress. Yeah.
Is here in Texas required to purchase my solar energy? We don't know.
Actually,
I think that's what you're talking about.
actually,
Go, James.
yes. FERC order 2222 that was passed a few years ago. Yeah, utilities are required to be able to accept and pay for.
So yeah. So, and I think that's also why the leading microgrid company in the United States is in Texas. Yeah.
That's the kind of regulation you're talking, right? That sort of thing, is that what you're talking?
Well, Texas is more deregulated than a lot of states.
Right.
Exactly.
Wow, right.
I thought the point of ERCOT was to avoid FERC regulations.
The point of ERCOT is actually to adhere to FERC regulations, right? So you have to be ahead of it. They're actually the guy that sits in the middle and actually measures and stuff as well. So you can get paid for it. I believe, and I'm not sure of the exact language in the order, but I believe you have paid at the average rate that utility is actually selling power at the time where it goes back onto the grid.
But they
So-
still,
so it-
there's still some loopholes. in
Oh,
terms of
yeah. Oh, yeah.
fees, and they can be jerks if they want.
And ERCOT actually takes the fee off of it as well.
But I would add in Texas, we've got two other things. We've got Smart Meter Texas, which is the 4 major utilities in the state keep basically the database of all the smart meters in the state and act as a group custodian of that smart meter data. So you talk about what's behind the meter in terms of billing. The other thing is you've got SPEER, SPEER, which is a nonprofit based out of Austin, but basically is all about how we're going to do some of these things, how cities are going to handle it, trying to get people to communities using similar language in their policies. So it's still early stages. It's still kind of chewing gum and baling wire, but we've got really good chewing gum and baling wire as opposed to a few years ago. It was really bad chewing gum. So.
But yeah, can you tell us a little bit more about how you're actually using game theory for this? Because whenever I hear a decentralized microgrid, I'm picturing essentially a large acyclic graph. And at scale, depending on what you're utilizing game theory for, it starts becoming extremely complex and less efficient. You start running into some of the limitations and problems of game theory whenever you're applying it to these sorts of scenarios. So if you could like elaborate on that just a little bit.
Yeah, so honestly, I even started reading on the thesis, doctor thesis of the founders of that company. But basically, I cannot like I could follow up with some documentation I can share, but what I understand is that each of the energy assets, the energy producing and storing assets, is programmed like as a rational agent, and basically like in an economic system, optimizing, telling when to sell, basically sell in theory energy, or put in energy into the system, and when not to, and so far like a microeconomic approach, optimizing at certain price points, through price points the output of their of the energy asset in particular.
So do you think it's correct to model this as a rational agent? Because we run the risk of running into the Nash equilibrium problem with this.
Into what problem? I'm sorry.
The Nash equilibrium problem. It's the limitation of game theory, where if you try to model two actors as rational and they're not rational, you can end up falling into an equilibrium that's not correct. It's not an accurate model of what you're trying to actually predict or optimize it on.
What I understand is that you obviously don't want to, I mean, basically with your algorithms, you can determine the rules of the game, yeah, and obviously you don't want to have zero-sum games, stages. So that would be my thing, that you create an environment mathematically where you create the win-win outcomes and prevent zero-sum games. That's but I'm not a super specialist on game theory now. Yeah.
I come from a software background, so that's a
yeah. So I think you're probably much more advanced than me, but I could, if you contact Gary, I will forward you the PhD thesis of the woman from, it's open, from Stanford University, who developed that system.
Okay, we'll check it out.
And it's really interesting.
So Gary and Volkmar talk every day.
Okay, give Gary.
Any other questions before we wrap it up? Okay.
All right, Volkmar, thank you.
Thank you. Thank you so much for having me, and wishing you all the best. Nice evening, and a wonderful, happy, successful new year. Thank you.
Thanks, Volkmar.
Thanks, Volkmar.
All right, buddy. Take care.